The contact between road pavement and tyre is essential for driving because the contact friction makes braking, steering and accelerating possible. Drivers usually learn to detect and anticipate the friction and other driving conditions, but the vehicle does not until it begins to slip. When friction is known, existing safety systems can react somewhat more correctly, especially in slippery conditions. But for future systems like collision mitigation, collision avoidance and curve speed warning, the knowledge of friction is necessary for their proper operation. Also, the so-called cooperative systems benefit when vehicles have an improved sense of friction, since, for instance, slippery road patches can be detected and reported to other vehicles and road maintenance. In recent years, the European Commission has supported safety policy aimed at reducing the number of fatalities and injuries on the roads. As part of the 6th Framework Programme, the Commission has supported a project called FRICTION. The project has developed continuous sense of friction and driving conditions on paved roads in order to improve the capabilities of vehicles to deal with changing road and weather conditions. Vehicles need to know two kinds of friction information: friction used and friction potential. Friction used is how much friction your driving maneuvers require. Friction potential is simply the maximum friction that your tyres can achieve on the current road pavement. Friction available is the difference between used and potential. Friction potential decreases when the pavement becomes wet. Friction potential decreases further when the pavement becomes snowy. Friction potential is small when the pavement becomes icy. The Friction project utilizes sensors from three categories. Sensors in the vehicle chassis, like wheel speed, steering wheel angle, brake signal, and yaw rate. They are becoming more and more standard sensors. Therefore, their utilization for friction detection does not increase the system costs. Sensors watching the vehicle environment detect if the pavement is dry, wet, snowy, or icy. Sensors include different thermometers, a laser scanner, a specific camera called the eye core, and a specific road sensor called a road eye. It is also possible to use a modified automotive radar. A novel sensor to measure tyre deformations was also used. This sensor enables tyre force calculation and detection of early stages of aquaplaning. It's not necessary to have all sensors in the system, but omitting some will degrade the sensing performance. All these sensors provide a lot of information on the road pavement, but the vehicle mainly needs to know friction used, friction potential, and road surface. These are calculated from the sensor information flow with complex data fusion algorithms developed in the project. With a fully implemented friction system, a car can detect friction as well as an alert, average human driver. The Friction project is coordinated by the Technical Research Centre of Finland, or VTT. The other partners are well-known companies and research organisations having expertise in sensors, ICT technology, tyres, vehicle dynamics and simulation. This project was made possible by European Commission funding.